Oh, don't forget, right here's the tomorrow's house. No?
I said the office. Yeah, my office hours should be out there. What rumors? You see how rumors get started?
Can we put it on the screen?
Oh. You guys want to see? You guys really want to see stuff?
I guess. I can't see.
Fresh credit.
Let me make a spot for it, guys. You guys aced the exam. You just told me you aced the exam.
Oh, yeah, in my dreams. Uh-huh. That's in my dreams. I was happy. I'll go later. But then I said, oh. Yeah, let me see that. I can't wait to have our 2 week break. Our 2 weeks of break. I know. She has the same thing as yours. That's so pretty.
You gotta get used to it because when you take the G test, that's what some of you take
At
your
least the
MCAT.
next one will
Yes,
get
yes.
a
Do make it.
So you have to write
Don't
on
fight
that.
it.
I will tell about that. I said that I found.
I don't get
I
it
said,
done.
"Girl,
that was my
it's
shit.
an afternoon."
Dr. Henry.
I got-
Why is that one?
I got just that. I said, oh my God, I dropped my baby off. I'm like,
That's a good question.
I think that was a good one.
Welcome to my world.
You could have saved yourself a couple dollars or you would have asked them first.
80 cents.
I thought they were dollars. Oh,
Oh, yesterday, you guys remember that?
You looked them up. I like. I wanted to like pretty.
after like 3 years, I
It
did.
was like
I have Billy, I got this 2 days.
You say give it example, you say it's drawn on the paper.
Funny tip.
Give me a chemical example.
Yeah, I want to make it with the actual bottle.
Yeah. And with the mom.
See, I'm funny too. I'm funny too.
The farmer's market.
It's on the bro one. That was the one that right there, right
You know,
there.
I think this one doesn't work because there's no power supply.
Oh, this one.
Yeah, it's connected to the air.
Yeah, it's beautifully connected there.
Yeah.
Connected to the air.
I literally like.
And they do.
Oh.
It was like a big city, then went to a small town. And I was like 10 when I moved here.
Oh.
Yeah.
It's a college, but it was college.
We just.
Then.
Are we just like doing like a wood diagram?
Do the Lewis diagrams of the.
Oh,
Maybe
okay.
we're like.
Yeah.
It's all great.
We'll be here at 8:30.
So they want that.
Yeah, basically you enter cinnamon and then you take a month, like you know how there's like a little curve? Do it faster. From going down into bush or no, this is the Russian. What's red? The trend on or what was that about? Yeah, this is the one.
Oh, yeah.
That one is the last one. You should go, it was white. And there was one that was the black one. That you made into- that was like a medium.
Wait, was it Tetra Eagle?
So, I don't know if you want to.
The first one has.
The white. Which is
Oh, that using that one.
carbon. That carbon is the. What was the trend one? Was it the one that was like H2O? Oh yeah, trend one. What's oxygen? Carbon, white one, the other was oxygen. Red.
I'm sure one of them is the little. What color was it? Was it black? We'll just make all the models. It have to be 4 or 5.
No, it will. Yeah, it's like for November. What's this have to those options? That was one of them too. And there was one that was like we used all white. Yeah, there was a black one.
Yeah, you're 4
Yeah, there was one that was cherry.
Was it the white?
I need to go home. I'm all like chloride. It's so early. I don't even know how to pronounce that. How
Chlorine?
No, it's because like every time like I know it's like Florida. So then like every time that comes into my I say
Chlorine. Or was it the fourth? I don't know if it was, I don't know if it was like that or was it two?
I think it was with small.
Does it matter? I don't think that matters.
And there was this one. It's like green one.
You should be under.
It's like the one from freaking Rio. They were sitting down. Dance hall. That's one of the-
And also like,
I don't know if it was white, like it was color. Was it three or was it four?
oh. We should find time to do that.
What?
So we can color on our values. So or they just because we're real quick and then we'll put them in order. Copy the one. I get what we're trying to do. Unless someone remembers that.
Go down to one. Yeah, but not in order.
Oh,
Just like this.
I'm not sure.
Yeah. Which one is what? What is that? Like, it would be what? That's tissue. Oh, what did you make?
I don't think that was good.
Or BH grade.
I wanted. No, that was the trigon. I think so. So we have.
Oh, yeah.
One,
So we would need the trigonal.
three, trigonal pyramid or trigonal five.
I think for that one, you were right. One of the trying to do this one to make chicken the first one. Yeah. I think one of them only had 3 sticks. We have 2 that have 4, so.
That's good.
Carbon and black.
Yeah.
You guys showed up well. Salma. Oh,
I want
Yeah.
to get my second to write out.
I need the red.
so let me know.
That's what check on the plan.
Can you do the whole day?
Not maybe I know.
Yeah, it is. Wait, you guys need another one, that's about it.
What time did Jesse and Cameron show up?
So I took them to dinner, and so we got there about
Just one time for Instagram set up.
yeah.
So you mean want the building, I want the photos of the building?
That's right.
Oh, we did.
For 5 days?
I'll take it away, you know, if you don't need it, you know, I mean, some of us just roll like.
This is number 3. This is bent and this is first.
No, it's joking, right?
Or bent. Where's bent? That's bent too. Yeah. That's bent with a V shape. Yes.
I think it's for right on the
Three.
field.
Where's the black one? I don't know.
I think that one's hard to do. Three of them or was it 4 of them?
For the triangle.
That's black.
Yeah, it's only black because you it's black because you don't have the.
Is there only one? Oh, no.
Yeah, there's. Oh, no, no. We're gonna go 2 whole circles. Oh, this is this one.
What?
Oh, yeah, yeah, yeah. And then.
Literally another one? Oh, that's, I found 3 one. Oh, yeah, yeah, that's right. What did you put? What did you put?
Oh, yeah,
Oh,
yeah. I was like behind them.
Oh, you're.
Yeah, well, I can barely see with the sun.
They weren't even big.
Not even, they were dead.
Look at that.
I supposed to give them some. Oh.
Wait, so huh?
Carbon. CH4.
There you go.
Should we try one? I know what was right? Oh, green. What was the try?
Fluorine is green,
What was the try on the floor?
so the halides are.
No, it's chlorine. Chlorine green. Where's mine?
No,
That
fluorine
one.
and fluorine are the same.
And then number
All your
2 is
halides.
this one. Number 2.
So should we write them down in here and then put the model on top of it on some page and then we can make the text? You work every day?
Oh, no, you don't have to put anything there.
Yeah. And so all the old tests. So like as soon as you get a grade, you go to work.
This goes.
I think so, yeah.
I see this.
I know.
What's your name? Put away. ¿Ya se gasta?
Oh.
Alpha boron. You said that. That's a good question. Let me know that it's boron. I think there's a carbon in it. Yes.
Can we check everything before we upload it?
No, just go ahead and upload it.
What am I wrong?
Then you're wrong.
Look at it. Just give me a- Does that look right?
What's that?
Does that look right?
He's like,
I don't know. I mean, it depends on what it is.
Tetrahedral.
Okay. You just like this way?
Oh. Trigonal pyramidal. Pyramidal.
Order.
Trigonal planet.
Okay. Okay.
It's stressed out over there.
Are you sure?
Yeah.
Are we sure about which one? That one, the last one, or all of them? Well, that was no trouble. He really was just true. Oh boy.
Not even.
Yes,
So tell me.
no. Yes, it is. Just with
He sounds.
yeah.
Yeah.
Okay.
That would be.
So normally you use the green to represent the chloride. So the halogens, all your halogens are represented by green. So chloride, represents green.
Oh, back there, yeah.
So your chlorine.
What's the end?
Yeah, you can just go and cross it off. Like right there, just put halogens. No, go ahead, do it. I'll do it. You're gonna do it, I'll do it. So you guys know. So you guys know that all your halogens are gonna be represented by the green. So then you just cross that out and say halogens. Yeah, cross out halogens.
Wait, so but what are you doing?
Because it's not there. It's not there. No, you're looking at the bond. You're not looking at the.
oh, they don't know which one it is. How do I get the water?
I need big water. Go get
I need to finish.
samples.
White and black.
Do you have the quiz questions for quiz? seven?
White. White and red.
Do I have the quiz questions for quiz 7?
Yeah,
It's
because
not-
some of the students don't write, I was gonna grade some of them for you.
It's not written up. It's not on the. Usually I type them up.
Huh?
I usually type them into the box.
Oh, into
Yeah.
this?
Yeah.
Check. Ask them now.
Did I not grade quiz 7 yet?
No.
This is good, right?
That's.
Okay, thanks.
That's $755.
Oh, there were your, okay.
You want it, I did quick with those. You just put it all together on one page together. Where's your third? I know she's online.
Oh.
That's what, children. Yeah. They're just a ball full of germs. Right?
There's not more problems. So much.
Can you guys sort of remind me of your different careers again?
Just a very strange when I retired. I think it's like
Okay.
ultrasound technician.
Doctor.
Doctor.
Yeah.
I know.
Dental hygienist.
Oh, she's on that.
I know she's on Zoom.
She texted us. Okay, so. Hi, Brenda.
Our daughter really is like that.
Red flag.
Hey, you know.
So got them ordered yesterday. And I did that. I had an order for you.
And then, oh, this is me?
Yeah, because it's not basically the.
You had a different one.
Yeah, you had a different one. What is the little one?
It was just a straight line. It was like red and blue, wasn't it? We can show- we can show it.
Look at that zipper.
That's why you're screaming. I was ignoring you. I was like, what's that? That's what it's called. That was how people slow. Okay.
I want to see that.
Use on the second one. For you. I feel like I found it easier. I found it easier for the second.
It stops.
Good point. I found it easier for the second one, 'cause I like that first two. They were only for the- Yeah, mine too.
I got stuck with the one that was like.
The J.
Oh, we have to wait for that one though, huh?
I know, I skipped the wave. I skipped the wave one. The wave. Yeah, it gave me the chart. Right?
I know, I put lithium,
Oh yeah.
I didn't know. Yeah, but what other regions? And there was the one that was like,
I
well,
didn't
they
think of
contract.
She said mine was I can't remember, mine was 6, 25.
I 272.
Yeah, see, mine was 6. No, 625.
No, but today is for this our girl.
Yeah, I got that one. Did you see those? Give an example. Or mention. What was that? I got the combustion earlier, right? Yeah. Lowers the volume of the property. And then this one's
First, oh, we do like that.
this is the one that was. I'm just saying some action.
No, we have to do it.
Okay. The sum of the world.
They have to do it. They have to do it.
Yo tampoco. I mean, yo estaba despierta. Así me quedé. Yes, you did. What time did you wake up? Oh my God, what's so early?
She was leaving for work.
I was like, what is it?
Well, she didn't wake me up on purpose. She woke up and she was right there.
Oh, okay. A mí me despertó a mí, pero no me quiero despertar.
You got wrong? Oh, then I probably get to.
But where that's what it's
That's when it's on the other side.
extra credit, yeah. On this one too. Extra credit points
Oh,
on like
did you
your
show me
job.
this one?
Yeah. Pero era como compromiso. No. Oh, FG. Oh, this is what I got one. Oh, so mine was different. Mine was.
All the galaxies.
It's
It's like the most recent upload.
And after that's the giant.
I know someone who has, like, all these little-
But definitely on the last day, start of class, the next day, I'm gonna eat a pizza. Figure it out.
Yeah, I take hours.
You don't? But then she had to be expensive. No, we went to freaking Women's, in and out, $14 for 2 burgers and drinks, and they're freaking change that for one person, it's like $50. Elaborate.
Okay, so you guys have answers?
Went up there. No, that's not even that bad.
Okay, so let's go ahead and talk. Let's talk.
I took it.
I don't know if it's available. It won't let us
Which
upload
was
it.
like, oh,
You want
like.
me to upload?
No, you said so, I took it apart.
Wait, upload what?
Pero soy. The thing.
I uploaded mine.
I found this one was hard.
What do you mean it's hard?
Like I couldn't do it. It got an odd number and everything. I was like, I give up.
Mine did not hard too.
I think I got that one.
I think I got it right.
And I got that one wrong. What'd you put?
You would think that would have been so freaking easy, but no, what'd you get? From BS. Freaking. Yeah, I don't know what's that.
What's
I thought it was straight up. Oh, shit, that's the crack too. How big was that? No, yesterday I was over the park. I did the little notice button. I went back. I mean, it turned on.
Yeah. I may have a weird answer. Yeah.
Are you allowed to change?
Saying that there's pizza.
There was a
There.
There's pizza was.
Yeah, and he's like, I think you were just home.
I've never seen it.
Yeah.
Where?
On
on the canvas? You just change it to the settings.
But I get it all the time.
I get it. I get like canvas.
Why am I being slow? You're
So
telling
you
me-
got the pizza one on there.
You got the pizza one on there?
I do that. You just.
I know, that's what I'm trying to do.
Okay, let me see if I can change that.
It's
That's
a
beyond
pizza.
my campus skills.
I got you.
I think you got to do it on yours independently.
No, I think it's
Yeah,
yours.
It's in your settings. I think it's in your settings.
I think it's yours.
Most schools, like, they have.
It's in my settings.
Yeah.
I was gonna say, yeah, I haven't seen it.
I would this semester, but see.
I'll look at it.
I just follow them.
Okay, so we have ultrasonic technicians, we have nurse practitioners, we have doctors, we have dental hygienists.
Oh,
Anyone else? Anything
For what?
else? Any other career?
oh, midwife.
Midwife. That's that would fall under nursing. Okay.
Nursing is not every week, so it's
We all want to do that. Good answer, good answer. Okay, so you guys are gonna have another assignment.
Just one.
Oh, 7, right? So you would do an actual teaching something else to figure out, right? But you can- I will let you do that.
Is it really good for living?
I really hope.
Oh, I look at that too.
What? Oh, where's that at?
So when I'm saying college work.
How much is it?
Oh, that's a what?
The one bedroom.
And then there's another one for 2 bedrooms.
And then
And then that 2 bedrooms is 700. I know. Well, I mean, you put what you want to put down and add to it. Or is that the deposit?
Deposit?
Or just put down money. So it's not like you
No, it's like it's soft. So deposit. That's much good, bro.
do it and then.
Okay.
There you go.
Everybody has it? Okay, so what would be an example of tetrahedral?
I tried doing 4.
CH4.
CH4.
I should have said, don't use any of the ones that I give.
You didn't make that clear, so.
Actually, we still kind of.
It's that time you
Okay.
have to add up.
So that's gonna look, who's gonna be in the middle?
So the 10.
How do we know that carbon's in the
I was really tired. What's the first one?
There's what?
It's the first one.
It's the first one.
And then there's 4
What was that?
hydrogens.
Why can't hydrogen be in? It can only hold 2 valence electrons, right? So if it can only hold 2 valence electrons, it can't have things attached to it. So it can never be. Okay, number 2.
NH3.
Try number 2.
NH3.
NH3.
But this.
Who's gonna be in the middle? What is trigonal pyramid? I mean, trigonal. BF. Okay, so. Okay. Lady.
H2O.
Wait,
Wait, I'm wrong. Wait, CO2.
CO2.
I know, it's like.
Okay, Bent.
H2O.
Any questions? Concerns? Cash? Relate? Okay, so those were all of the molecular geometries. Let's talk about their, since you guys have them up here, let's talk about their electron pair geometries. Electron pair geometry. So you're saying trigonal pyramidal, that would be its electron pair geometry.
Isn't it an
So you're saying
APG?
this is electron pair geometry. So what would be its electron pair geometry? For the that would be tetrahedral. That's right, because there's 4 attachments. The lone pair counts as an attachment. So it's electron pair geometry is going to be tetrahedral. Because there's 4 things that are going to be attached. The lone pair counts as an attachment. Okay. So what about water? What is an electron pair geometry? Look at the center atom. Center atom for water. Oxygen. It has 2 lone pairs. So each lone pair counts as an attachment. What else in tetrahedral? Electron pair geometry. Okay, what about carbon dioxide? Center atom. How many atoms is it attached to? How many lone pairs? That's for lone pairs. Lone pairs means dots on top. Dots. Any dots on the carbon?
No.
No dots on the carbon. How many things is it attached to? How many atoms is it attached to? It's attached to 2. So then it's going to be.
Oh, alright. Basically,
So if there's no lone pairs on top of it. Okay, what about for number of attachments? Number of attachments for method. 4 attachments. 4, so then 4 would be what?
Okay, I really do understand.
Okay, so if there's 4 attachments, lone pairs counts as attachments for electron pair geometry. So then that means there's going to be tetrahedral. If there are 3 attachments, it's going to be trigonal planar. If there are 2 attachments, okay. Yes, you got it. Everybody else, how do you guys feel? Repeat that. Or you guys got it?
Practice.
Again, trigonal pyramidal only be molecular. Yes. It will only be molecular.
That's what
So it's not G.
It's not electron carrier. Okay. What's that? Yes. Okay, so let's go forward.
9 o'clock. 9:07. Go ahead, Louis.
Okay, let's see. Okay, so I'm going to teach you guys one other thing, all right? We're going to talk about formal charges. It's not in your text, so you guys are going to have to just pay attention. Take good notes. And we're also going to talk about version instruction. Ridley, can you hear us?
Yes.
You're on mute, so I take that as yes. Okay, so we talked about in some cases we have what we call hypervalency. You guys remember what hypervalency was? Excessive amounts of those electrons. Okay, so in other words, that we have more than 8 rounds, right? So we break the octet rule, we screwed up the octet rule. Okay, so the way that we determine whether or not something is going to be hypervalent or not is by using what we call formal charges. So the formal charge is going to be the number of valence electrons minus bonds minus number of lone pairs. So that's how you calculate the formal charge. Formal charge, you want to try to get as close to 0 as possible, right? You want to get it close to 0 as possible. The closer it is to 0, the better off it will be, right? If it's a -1, that's okay. If it's a -6, that's not acceptable, right? If it's a +1, that's okay. If it's a +10, that's not acceptable. You want to get as close to 0 as possible. Okay. So, if we take a look at this, this polyatomic ion, what is this polyatomic ion called? Okay. Okay, sulfate. So if we take a look at the sulfate, who's going to be the center atom? The S is going to be center. How many valence electrons does the S have?
6.
It has 6 valence electrons. Okay, and then the oxygen has how many valence electrons? Okay, this means what? This is -2.
You add 2.
We add 2 more electrons. It's 32 electrons that we're working. Okay, so we have 32 electrons. The easiest way to do this would be putting those other 2 there, right? So then everybody would have 8. One, 2, 2, 4, 6, 8. 12, 14, 16, 18, 20, 14, 16, 8, 30, 32. 4, 6, 8, 10, 12, 14, 16, 18, 20, 24, 16, 30, 32. 32 total electrons. Okay? Everybody has 8 around them. So technically, that would be half. Right? Okay, so now if you look at the formal charge, you want to take the formal charge of your center atom. Right? So if you take a look at our formal charge of our center atom, how many valence electrons does sulfur have?
6.
It has 6 valence electrons. How many bonds do we see here?
4.
We have 4 bonds. And then how many lone pairs do we have? Okay. So we add this up, it gives us a 2 charge. Okay, now a 2 charge is not an acceptable charge. It doesn't like to have a 2 charge if you have something better. So what it does, it'll try to change its valency. So in other words, it'll be willing to accept an extra in this case, so that it can get a 0 charge. Okay, so, and by the way, it should add up altogether. When we do the whole thing, it should add up to -2. Altogether, add up to -2. Take a look at this guy. We want to try to get this guy close to 0, right? We want to try to get it so that they're all close to 0, right? All of them. So if we take a look at the sulfur, so we have 6 minus 4, 5, okay, 0. So we have to give that a +1, right? Yeah, another, so let's add another on the other side. Okay, so then that's in 6. Okay. So if we take a look at this guy and this guy, the oxygens, we look at its formal charge. This oxygen is valence number 6 minus, it has 1 bond, and it has a total of 6 valence electrons. So altogether, that's a -1. And then this one here is also going to be a -1. Same thing. And then we have these 2, which is going to be, we have valence electrons minus minus the number of bonds, 1, 2, minus the number of valence electrons. Okay, so then the other one would be. Okay, now all together, if we take a look at all of the formal charges. Formal charge on the S is a 0. Formal charge on this oxygen is a 0. Formal charge on this oxygen. This oxygen is 0. And this oxygen is 0. So we'll call this one 4 and 3. 2. 1, 2, 3. 4. So, okay. Can you guys see that? Okay. So we want to try to get our formal charge as close to 0 as possible. Now, if the compound or the molecule has a charge associated with it, the formal charges have to add up to the charge that it has. So it has a -2 charge. This is -1, -1 plus -1 is what? -2. It adds up to the sulfur. Okay. Okay. So we got these as close to 0 as possible that we can get it to. So this here would be better than the one that had a +2 charge. Although for your case, like if you guys do it out on the exam, right? I want you to do it on the practice exam. I'd accept that first model, the one where we had because it's based upon the octet. So sometimes the octet, having the octet is not stable. This here is more stable than this guy. Okay. So this guy is going to occur more frequently. This guy can occur. It does occur in nature, but it's going to be less frequent. Okay. So these guys here would be considered resonant structures of each other, right? A resonant structure is just the movement of electrons from one position to the other position, right? When you have things that are similar. So here we've just moved electrons around from one structure to the other structure. That would be considered a resonant structure. Okay, this guy is more stable, so it's going to occur more frequently than this one. So because it's unstable, it's going to keep moving until it gets closer to this. Does that make sense? Okay. So let me write that down. Resonance. So if something is resonating, it basically means like movement, right? So have you guys like a pitchfork? You smack a pitchfork on the thing, goes zzz, that movement is called resonating. So resonating is just basically the movement of electrons. Okay. So your electrons are moving, not that you're changing your structure, but your electrons are moving from one, let's say one O to the other O, right? Then that means it's resonating. So that's a resonant structure. Okay. How you guys feeling? Good, not so bad, right? So if you guys go to Chem 101 and you guys play with the Lewis dot structures and everything like that, there'll be a couple of questions that talks about formal charges. And so your goal is to try to get those formal charges, but they ask you find the structure based upon formal charges. And you want to try to find it so it's closest to 0 for all of your atoms that are in that molecule. Okay, you want to try one more? Or you guys?
Yeah, I want one.
One more.
Ray Charles. Ray Charles.
Yeah, charger.
Let's do that one. Okay, she's gonna be in the center.
Oh, I'm sorry. Oh.
Oh.
Are you sure?
Yeah. Oxygen, right?
Nope.
But is, you know.
All right. Okay, N's gonna be in the center. Why? Why is N gonna be in the center?
I don't know. It was like because the oxygen. They were in the south.
That's oxygen.
What was it?
Oh, no, nothing.
So if we look on it, because oxygen and nitrogen are on the same level, right? They're at the same period, right?
Yeah.
Are they not? So electro what?
Something about.
Electronegativity.
Yeah, whatever.
Oxygen is more electronegative than nitrogen.
So
right?
whatever's more whatever's
Negative.
negative goes in the middle.
No, the one that's the most electronegative is gonna go towards the end.
Oh.
Unless they don't have a choice, like in the case of water, where hydrogen always has to get.
Okay.
Okay? So, in the case where you have options where either one of them go there, so then in that case, the one that's most electronegative is gonna go to the end. Kind of like, okay, so, do you guys have siblings?
Yeah.
Okay, how many siblings you got? You have one? You got two siblings? Who said this? Two siblings. Okay, are you the youngest, oldest, or middle? We're the oldest. Okay, so I'm the oldest of my sibling. He's also the oldest of his siblings, right? So when you guys go on a car trip, you know, usually there's 3 siblings in the car, right? In the back seat. So who gets put in the middle?
The little, whoever's smaller.
The little one or the weakest one, right? So whoever's the weakest gets put in the middle, right? So that's the same thing that happens here in the case of atoms. The one that has the weakest electronegativity is going to be put in the middle because they're weak, right? So you bully around the weak one, right? Isn't that true? Don't tell me don't lie. Come on, be honest.
I was getting fucked up every day.
So you're baby.
Yeah.
Yeah. So yeah, because I know we put my little sister until she got bigger than me, we put her in the middle, right? So, and then when she got bigger, then I got put in the middle, right? So I'm like, okay, well.
Wow.
Okay, so the weak one gets put in the middle, right? So that's the way you want to remember. Think about if you had siblings, you're gonna put that sibling. Okay, so nitrogen is gonna go in the middle. How many valence electrons does nitrogen have? 5. Okay. Oxygen. Okay, so that's 10 plus 6, so we have 60 to work with. So how can we rearrange this so it works? How can you rearrange this so it works? So that everybody's octet is reached.
Don't you have to like put the bracket or something on that one?
There's no electrons on it.
Okay.
The other one we should put brackets on. Thank you for reminding me. I don't want to know the geometry. I want you to show me the electron evolution. Okay, so they're definitely going to be bonded in the middle, but how am I going to bond them?
3 and 2.
I can do 3 and 2. So you said 3 on one side, 2 on the other? Okay, so what is the rule? about this?
I don't know.
The octet rule. So there's an octet rule. There was an octet rule. When can you break the octet rule? Where do you have to be to break the octet rule? Okay, so it's uneven, right? But this is an even, 16, right? So that doesn't count. When can I break the octet rule? Okay, boron is an example that we could have break the octet rule, but that's an example of deficiency, right? This would not be an example of deficiency. Anybody remember? When can I break the octet rule? When can I have more than 8 around? I think. What was it?
And a D subshell in the skeletal.
Oh, you're close. You're really close. So when does the D subshell come into play? Which period? So what period does it come into play? Fourth period?
The fifth
The
period,
third,
right?
the third period, right? So the D subshell comes in at the third period, right? So anything that's the third period and above, the D subshell comes into play. So that's the only time that we can use that, right? So is oxygen and nitrogen in the third period? It is.
No.
It's not. So can it break the octet rule? It can't break the octet rule that way. It can have less, right? It can have less than 8 if that's only on odd numbers, right? Is that an odd number? So it can't break the octet rules. This one can't work. Okay. So come on, help me out here. We had one guess. It was close. You were getting close. Just kind of work around a little bit more. You guys got this. I believe in you. What? Why are you giggling?
My notes.
So you're saying take this one here.
I'm sorry, sir.
Talked about
Can you repeat the question?
I like that.
So can you repeat it one more time so I can let my brain process?
Draw the Lewis structure for this guy, so that everybody reaches his octet. Yeah, you can. I mean, electrons are moving. They're moving. So you're saying
Don't you put three in the middle of both of them, right?
So we're saying that. Okay, then we're doing this. This. How am I going to? I'm just doing what you told me to do. I put that over there like you told me. Is that what you wanted?
Can you put 3 long scoops there?
So you're saying, okay, right here? Okay, so is that- is that-
Can you put 3 lines on the between the nitrogen and then one on the other side?
So you're saying I'm doing this. In response here. In
And one.
one. That works. So that's a summation of 2, 4, 6, 8, 10, 12, 14, 16. That works. That's one possibility.
Yeah, he's doing like that.
Okay, I have this. Okay.
Yeah,
and
but
then-
he put.
But that would be no different than you write it out.
Yeah.
So tell me how many are you have?
Yeah, two.
Pretty much.
Oh, I did that, right. Good job, baby.
Okay, so let's count those. That's 2, 4, 6, 8, 10, 12, 14. That works. Okay. Any other possibilities?
That's why I didn't know
Come on, we got one more possibility. What is the other possibility?
I don't know. I don't know.
I don't know, maybe if you, shoot through, I don't know. Yeah, I can.
Keep thinking it's there. I feel it. I feel it. I feel it in my bones.
And the two pairs, whatever, and in the middle, you put 2 dots on top of that, and or no?
I'm gonna put 2 dots on the other end.
In the middle.
In the middle. So I put 2 dots on the one in the middle.
Put 2,
Okay, 2 here.
and the dots, and then,
Oh.
no, the line, you gotta put it, a line after the.
Yeah.
Wait, it was just-
No, like,
Never mind. Never mind.
Okay, so if I put 2 dots here, it's still like that works, right? So that's 2.
so you just gotta put the 2 dots on the top of there.
12, 14, 16. Then that would be this one. 6, that would be this one. That would work. This one doesn't. Okay, any others? Come on, there has to be one more. Come on, you guys, can't you see it?
No.
No.
Around a little bit.
You put 7 dots on the first end.
7 dots on the first
Yeah,
end.
with one
Okay.
dot in the middle. Like, I mean, towards the other end.
So you're saying 7 dots here.
But that's not, they don't work. It's not, 4, right?
Which one? This one here, but flip? Yeah, okay.
I was looking at when I was like, oh. But you can.
All right, remember electrons are moving. Okay, so we have 3 possibilities. You have this one, and this one. You have 3 possibilities. You guys see it? Let me underline it.
Oh my God,
Yeah,
it
lots
is
of
the
them.
same. Look it around.
This one. Can you guys see it?
Yes.
Are they showing up over there? Okay, so those are our 3 possibilities. So, according to the octet rule, all of those possibilities are a possibility, right? But according to the formal charges rule, they may not all be a possibility. So let's calculate the formal charge for each of the different ones. Fine if I erase this over here. Erase this part here. So we're gonna do the formal charges of this first one, put in green. Then we'll do the formal charges of the second one, we'll do this one in red. And then the third formal charges, we'll do it in black. All right. Anybody? Okay, you guys gotta help me with formal charts, because you know, I'm a newbie at this, help me out. So, let's start off with this first end. 1, 2, 3. Okay, so that first end. Okay, so what will be the formal charge of that first end? So, valence? Valence electrons. How many valence electrons does hydrogen have? It has 5 valence electrons. Okay, so then it has
How many dots?
number of bonds.
That's with the, what is it, the bonds?
It has 2 bonds. Then how many lone pair electrons? 4. Okay, so we add that together, so that gives us -1. Okay, second end. The end in the middle.
Okay.
Number of valence electrons,
5.
number of bonds,
4.
number of lone pair electrons.
So what's the lone pairs?
That's plus one, right?
Yeah.
And then our O,
I don't get that either.
Yeah, there's the.
One to
Or.
4.
Oh, 4. 1, 2, 3, 4.
okay? So we
Oh,
got zero,
it's a
right?
one dot.
You guys got that?
Yeah,
So
so
it's
zero.
that it had four.
Okay.
Which one is it going based off of?
Huh? Tell me about it.
I don't know why you don't utilize.
Well, I see it. You have that.
It's because they don't. So we'll do, again, this is 1, 2. Okay, so first in. How many valence electrons?
5.
Okay,
We don't, I'm sorry, you said. The completion, we don't do all 3.
we do,
Do the 1.
no.
Oh, okay.
Yep.
It's in 3, you know, there's 3.
Yeah.
All 3, all 10.
Well, not, we're looking at the formal chart section. These are all different possibilities, right?
Okay.
And we're just trying to figure out the one that's the most probable. Okay. Okay, so then the second nitrogen.
5,
5,
4, 0.
then the oxygen.
6, 1, 6,
That's the name. Okay, and then our third possibility.
5,
5,
1. Is that 6?
negative 2. Okay, negative 2.
5, 4, 0.
Okay.
6, 3, 2.
Okay, so. Is that better? Okay, so let's talk business here. Okay, so who's electronegative? Who's the most electronegative? Oxygen. So in this case, the one that would be the most stable would be the one that's closest to being 0. So it would be either this one or this one, right? But if we're going to have charges, we want the charges to be on the one that is the most electronegative. Who is the most electronegative, you said? Oxygen. Oxygen is the most electronegative. So we want the negative charge to be on the oxygen. So this, number 2, would be the one that's stable.
So, no, so you tell me to solve the problem, we gotta do all these steps?
So this is for formal charges. Yes, this is to solve a problem for formal charges. You would have to do all these steps. Okay, so now I said earlier, formal charges is extra, right? The reason why I'm giving it to you as extra because you're gonna need it later on, right? Later on, if you guys go into organic chemistry, you're gonna need it because you have to deal with resonance structures, right? Okay, and all of you guys who are planning to go into dental hygienist, ultrasound tech, and some of you guys that are planning to become nurse practitioners will have to take organic chemistry. the second one. So you're gonna need to know this, right?
Would our later look and know that that's the one?
No, but if you do it on Chem 101, it'll actually calculate all the formal charges for you. It'll give you the
Set ourselves
reference.
up.
So if you pick that button that says formal charges, it'll do it for you, right? Okay, now, the thing is that, again, all of these possibilities exist, they happen, right? But the one that is the most stable is gonna be the one that's gonna be the most abundant. That happens more frequently. You guys understand? So, in other words, this happens in nature, but it's very rare, and so it changes real quick. But this one is more stable, so it's gonna be around longer. Okay? You guys understand? So if you're stable, you're gonna survive a lot longer than if you're not stable or unstable. Right? So crackheads typically don't live a full lifetime. Some of them, but most of them don't, right? So you guys kind of get that? You understand that? Okay, questions? Concerns? Cash. Okay, so again, when we talk about resonance structures are the movement of electrons, where electrons are moving, right, from atoms to atoms. So that's a resonance structure. I'll show you another example here in a second. Okay, so let's go ahead and draw the Lewis structure for our hydrogen carbonate. Carbonate ion. And let me give you guys a hint. So anytime that you have like hydrogen carbonate, there's a possibility that that hydrogen is going to be off of the oxygen rather than that center atom. Got it? So this is me.
Huh? You also have
I don't even want to see. Like my first. 7 out of 10. Whatever.
Give
another one?
Oh, mine was 7.
Oh, yeah, but you kept me
That's what this is.
No,
Oh, mine was 8. Mine was 8.
Oh, so you don't have
That's
water?
reasonable. What?
What? Really? Why? Do you have too much debt? Your credit score is awesome. You have a little.
Which is?
No, that's 15. 8. Quiz 8. Oh, quiz 8.
Quiz 8, I got it.
15 out of 15. Go.
Life is not fair.
What'd you get? Maybe she's still
Oh, you really didn't put it down. I just wrote it.
And
Okay, you guys got it?
Oh, yeah.
Lewis structure. You guys are like, what are we supposed to be doing?
we're looking at our grades.
You guys take a break and then you guys are.
I just did.
Oh, we're looking at our grades. I'm gonna finish my coffee now. Shooting in time.
I know. They messed up on our order today.
They gave her like 3 drinks and food.
For real.
Oh, really?
They messed up my
Yeah.
order too. We saw cheese Danish and then the coffee like, what's this? And it says her name. You want more? And she got an extra coffee.
Wow.
I don't know. It's free.
It was a good day today. No, it wasn't. Finish on my sandwich. Yeah.
You screwed up your sandwich?
They didn't have
They give it
it.
to her.
Oh.
Well, she ordered first, second.
Yeah, but I had to order Janet's.
Well, whose fault's that?
Janet's. Like type on my page.
Okay, you guys got it?
Yeah, you guys.
You scared?
Sure.
He's gonna like come back tomorrow.
I don't believe that. So I was going.
Faster
than me.
That's right. it's your oxygen.
That's it.
Not technically,
I did
it's your
too.
oxygen.
You were you the one with the sunglasses? I know.
You got it?
My second one here is-
You're not even huge. Calm
Yeah,
down.
like- like, what?
They're normal size.
Yeah. I was like, who's John?
My chemistry class.
They look like it.
So one has four and six.
Huh?
That's what it would be, right? You add those.
Yeah, you gotta try. Do not
Maybe
try.
11?
You know, just try.
What
Even though you know we have the answer already there for you, but try. 'cause It'll help you get your thoughts together.
I didn't know that.
Okay, tomorrow, we're gonna start off with the lab. So the lab tomorrow, you can't do. So we'll have you guys come like an hour and a half later. Like everyone else.
You shouldn't have to.
We've gone for a couple days or something. What was that?
Well, I'm an evening, so it's not gonna make because like I get like.
No, it's not gonna affect you.
Okay. Just making sure
You can
people who
get out
are
of this.
pregnant or no, I'm just making sure. too,
No,
because
this
I think I
is
get
just a
lightheaded
little
real quick.
radioactivity.
It's a what?
A little bit of radioactivity. You'll be okay.
You the husband.
What chapter is
Look at that, man.
I told you. ¿En serio hay muriendo? Las cucarachas. They're over the floor?
Yeah, you guys have answers for me.
Mejor me traigo
Yeah,
una.
like answers. Okay, so you could be in the middle. Carmen's gonna start off in the middle, right?
I see, and I see because we're seeing it. Carbon monoxide. I look and I'm like.
Okay, carbon has how many valence electrons? 4 valence electrons. Okay. And oxygen. 6. Okay. Plus 4. So we got 2 and 2 going on right now. And then hydrogen has. Okay. And then we also have an additional one, right? We have 24 electrons to work. Additional one, and then we have hydrogen. Right? Why is it so tight?
So all four, like, Sarah.
Not necessarily. I told you.
We hear
it. Sometimes
Maybe
that
she-
hydrogen will bond to that oxygen. Yeah. Four, right? That's hydrogen.
I keep walking.
So then that's 24.
She's like,
This is the oxygens.
Okay, so. we can start. Shorter, right? Six over here. Suggestions? So sometimes what you're going to need to do is take this hydrogen, and put it on the other side of it on. Right? So we'll go C, 4 here, we have that one extra. So that makes it oxygen here. So we take 6 1.
Yeah.
Okay. Now let's count. That's 2, 4, 6, 8, 10, 12, 24 electrons. 8 around this oxygen. 6 around the carbon. Right? 2, 4, 6, 8 around this carbon. 2, 4, 6, 8 around this oxygen. 2, 4, 6, 8 around this oxygen. 2, 4, 6, 8 around this oxygen. 2 around the hydrogen. Right? Okay, questions? Concerns? Cash? Kool-Aid? Hey, you guys in that corner, you're wearing it. You have that look. It's like fear. I see fear in this.
It is.
I have no fear, but I have no fear.
Okay, so if it's not working out, you can't find the 8, right? Sometimes if you have a hydrogen and an oxygen, right, that hydrogen will bond to the oxygen, okay? So just kind of keep that in mind. So that's another possibility,
Oh,
okay? So where you have, in that case, 2 center atoms, right? You have one of the oxygen acting as a center atom, and you have the carbon acting.
So are both of those correct?
Yep.
Yep.
No, this one's
Oh.
correct. This
Oh.
one isn't.
Okay.
Because we didn't have enough on this one.
Oh.
Question, concern, so let me. This one. This one. Yeah, we can play with this for days and so on. Okay. And the best way of doing it is practice. Okay, so we talked about resonance structures. So this is what I mean by resonance structures. You guys take a look where the double bond is at. Okay, that. Each one is a resonance structure of this compound. Now, all it is the movement of electrons, right? So if you guys take a look, we're moving from you have double bond on the third oxygen, here it's on that second oxygen, here it's on that first. Right? So the difference between these is that the electrons are moving between these. So these are considered resonance structures of each other. They're different from isomers. You guys remember what an isomer is?
Same chemical formula, different chemical structure.
Same chemical formula, different chemical structure. So in other words, they have exactly the same number of carbons, exactly the same number of oxygens, exactly the same number of hydrogens, but they have different number, the structure is just different. Okay? So let me give you an example. So if we have acetic acid looks like this. Did you say you're too old? Okay, so this is acetic acid. And so, and this is called ethyl, ethane diethyl. Okay. So if you look at the number of carbons that they have, C2, H4, O2. This guy, C2, H4, O2. So these are two different chemicals. They're going to behave differently from each other. They're going to react differently. Right? But they have the same chemical formula. So when we're talking about a lot of organic chemistry, we talk about the difference between those two chemical compounds, how they behave, their properties are going to be totally different from each other. So they're not going to react the way that we anticipate them to react.
Did you get this thing unplugged? Broken?
It's broken. So, pretty simple, right? You guys see the distinction between them, right? You see physically the structures are different, but they have the same chemical formula.
That makes the difference for it.
That's right.
So whatever structure it has, it will tell you basically what that.
Yeah. And so when we talk particularly like drugs, a lot of times
Like prescription drugs?
prescription drugs. Prescription drugs are a good example, right? So prescription drugs, a lot of times will have a chemical formula that's associated with it. But that formula doesn't really mean jack shit because we need to know the structure, right? And so we need to know how that structure is drawn, right? So you'll have something that will have the same chemical formula, but it's going to behave totally different. Right? So remember I told you about L-glucose and D-glucose, right? One of it being a poison and one of them we can actually process. So
So how can you tell it's different just
You just said the structure.
on the structure. So this one double bonded to the carbon, the oxygen double bonded to the carbon. Here, the carbon is double bonded to another carbon. See the difference? Structurally. So a lot of times with organic chemistry, we have to draw the structure so that we know what we're talking about. Where, you know, in organic chemistry, we typically get away with not drawing structure. You can just write down. Okay, so that's one of the major difference between inorganic chemistry and organic chemistry. Although there are complex structures in inorganic chemistry as well, and sometimes you have to draw them out, but in most cases you can get away with just writing the chemical formula, right? So because we always know that H2SO4 AQ, what is that? Was it? H2SO4 AQ. Oh, you guys can't forget it already because you're gonna have it.
Is it like dihydrogen something?
Nope.
Oh, I don't know.
AQ is the secret. It's an acid. Okay. It's not hydro because there's an oxygen in it. Sulfuric acid, that's right. So we always know that H2SO4 is sulfuric acid, right? Where C2H4O2 could either be acetate or it could be ethylene dithiol. Okay. So and this is an example again of an isomer. Iso meaning same, and then mer meaning unit, same. Okay. How you guys feel? Did you guys get that all down? Everybody got it down?
Oh, wait, hold on, let me finish.
Okay, VSEPR. VSEPR stands for valence shell electron pair repulsion period. We've already talked about it, right? We already talked about how electron pairs will repel each other, so that means they're going to try to be as far away from each other as possible. We sat together and remember that. You'll never forget that, will you? Right? So that's the VSEPR. Okay? It just basically means that electrons will repel each other and they will try to distribute themselves to be as far away from each other as possible. Okay? So you guys are already familiar with the so here are examples of electron pairs. So this is an example of an electron pair here, an electron pair here. They're going to try to move as far away as possible. So they're going to be 180 degrees from each other. If we have 3 electron pairs, they're going to be 120 degrees. If we have 4 electron pairs, they're going to be 109.5 degrees. Okay, this is just basically showing you what it would look like with a balloon. And so this the balloon kind of represents the electron cloud because remember the electrons are always moving around molecules. So this is 2 or 3 balloons. Okay. So 120 degrees. This is 4 balloons. 109.5. So this here basically shows you the electron pair and the molecular geometries. We've already talked about this. You guys already know most of it, right? Feeling confident? So we talked about the electron pair versus the molecular, the electron pair geometry versus the molecular geometry. Right? So you guys should be very comfortable with this. This is just showing you that these are all, this electron pair geometry is all tetrahedral, but this one is, it's molecular geometry. It has 4 attachments, tetrahedral. It has 3 attachments in a lone pair, trigonal pyramidal. If it has 2 attachments and 2 lone pairs, then it's going to be bent. Okay. So the wedge dash diagram. So the way the wedge dash diagram is, it's a way of helping us orient or draw things that are three-dimensional. So the way I like looking at it, the wedge is going to be a solid piece. So it's going to look like this, like a triangle sort of. Okay, the dash is going to be your Wi-Fi signal. You guys have that Wi-Fi signal that shows. Okay, so wedge dash. Okay, so your wedge is going to be coming towards you, and the dash is going to be going away from you. Okay. So if we were drawing, let's say, right, we have one that's going away from us, one hydrogen that's going away from us. Here. And then we'll have one that's going on us. And then one that's going to be within us. Okay, so this here represents my horrible. So that just basically means it's behind, right? This one's in front, that one's behind, and that one's in the same. Okay, you guys got that? That's just basically, it's just a drawing. Okay. We already talked about how you predict the geometries. Very good. So draw the wedge dash for NCl3. Who's going to be in the middle? Okay. How many valence electrons does hydrogen have? 5. Chlorine, how many valence electrons does chlorine have? 7. So if we're going to do a wedge dash of this, in back.
You can put all those lines over there. So there's not a limit to how many lines you can add.
It's just as long as you can see, as long as you can make out what it is. Somebody else can. Okay, so we have one going towards the back, one going towards the front, one in the same plane, and then we have the dots on top. Okay. You got a question?
Okay.
Questions, concerns, Cash? There's a pretty good. remains the same. Okay. So we talked about, so when we talk about multiple bonds, so let's say it's a triple bond versus a single bond versus a double bond. So that single bond or that double bond, that's just going to count as a single attachment. So we're going to look at it as an attachment. Okay. So like for instance, on the board over here, that center atom, the carbon. Yeah, I like it controls this one. Okay, so this center atom, this carbon, right? It has 3 attachments. Are there any lone pairs? So this counts as 1, 2, 3 attachments. So since there's 3 attachments, what would be the shape? What would be its geometry? Trigonal planar, because there's 3. Trigonal planar, that's right. Okay. So if there were lone pairs, if there were 2 lone pairs that were there, then we know it would be bent. Or if there were a lone pair there, that was there. Okay. So in this case, trigonal planar. What about this oxygen, since it's a center atom as well? What's going to be the shape of that? There's 2 lone pairs and 2 attachments. No, not linear.
Oh.
Now that would be its electron pair geometry. So how about its molecular geometry?
So is that?
Was it angular or bent? That's correct, angular or bent. If there's 2 lone pairs, it's going to cause it to be bent. Okay. But even though we draw it like it's a straight line, it's really bent. Kind of a kink to it. Okay. Okay, so here we have, draw the molecular geometry. Draw the Lewis dot structure for C2F4. That means we're doing here. Carbon is going to be the center atom. So you have 2 carbons that are going to be center atoms. Okay, and then what I like you to do is draw the molecular geometry for tetrafluoride, tetrafluoro, ethane.
Oh, I see.
Yeah, it's a type. So there should be a E here. Carbon's going to be center. So since this is an organic structure, you know it's going to be Okay, you guys ready? Okay, so who's gonna be the center?
Carbon.
Carbon. How many valence electrons does carbon have? Eight. Fluorine, how many valence electrons does each of fluorine have? 4. $36. Okay, that's just the structure. So when we draw the structure, we don't have to include the electrons. So if we draw a wedge gas structure or just a structure in general. So how would we draw this? Wedge gas. Okay, so who will be in front? Which would be the same, right? So if you guys can do me a favor, go in your modeling kits, make a structure.
The first day. It was the first day, yeah. So- These are yours.
What color do you want to use?
Green.
So
But make sure that you use the carbon that has 4 holes. 4-hole carbon. 4-hole carbon. Two 4-hole carbons.
So we're drawing H.
I know that's not.
You put 2. 2 of them. it says about long. It says. So you gotta take a look at it.
Why does it matter?
It's just to give you warning, so if you want to make it 3D. This one, it doesn't matter because it's all planar, right? This guy, it's all in the same color. All of the atoms are the same, right? So this guy would be trigonal planar, this carbon trigonal planar, this carbon trigonal planar. Planar matters in this case, right? But if there was, do me a favor, do ammonia again. Make it ammonia for me.
No, I'm meant to be
You're gonna keep this? Now, if you look at it, it's all in the same thing. Okay, so this guy, it doesn't matter if you go like this, because literally we're showing it. If you guys, that very first picture, showing it like this.
I know.
What can I say? They were. Yes.
Oh.
Okay. Okay, so
Oh,
if you guys take a look at it, right, if it's like this, it's this first case, right? But it's all in the same plane, right? All of your atoms are in the same plane. Okay, if it's like this, this is going to be in this case.
Maybe that's my problem.
Okay. So it's the same thing.
So the white and the dash.
No idea.
So that.
That's right. It gives it, it makes it this way so that it's coming out towards, you know? So you guys see, coming out towards, you guys can do me a favor and do ammonia. Yeah, that's ammonia. Without the third one up there. You need this. Yeah. So this is ammonia, right? So if we take a look at ammonia, we have the one that's coming out towards us, right? The one that's going towards the back and the one that's in our plane, in the same place, right? Out, back, same thing. Okay. So that's the, and that's what, I mean, literally it's just so that you guys can get the concept that there's a 3D structure to it, right? Rather than just.
For this long.
That was the last one.
There's a double bond when you do it like this. So the long way it says double because it's stress. Right? Double or triple. That's right. You're not supposed to be full. So the only time that you do, because they're supposed to be honest about the whole concept, is everybody needs to go out. So as the model comes in, yeah. This is- You need to do your. Everywhere you're. That's like this.
I think my brother watch that. Yeah, actually. So no,
like there's like literally I was sitting and then I was like, I like
That's just so funny.
I know the
What is it?
No, never mind. Gilmore Girls.
Rory.
That one girl.
Yeah.
Okay, are you guys good so far? Beautiful, beautiful,
Thank you. I
beautiful,
tried
beautiful.
really hard.
You didn't go mine.
Okay, wait, is that right? Is that correct?
This, oh no, I was playing around.
Oh, you're missing one. Is it supposed to be ammonia? Not ammonium.
Oh,
Ammonia.
you're making something go
What is the chemical formula for ammonium? Is NH4. NH3 is ammonia.
Oh, so I did a little. Okay.
You were
Yeah.
this close.
This close, but not close. Not too far.
You guys are, I'm impressed. You guys are correcting each other now, which is good. That's a good sign. It is. That means learning, right? Before it would have been, you all would look at me, right?
So it's ammonia and what?
That's it.
ammonia?
Right? Ammonia, that would be
Leave me
ammonia.
alone, I'm
and
proud of what I
ammonium.
did. Ammonium.
Yes, that means that you have that H and it's a plus. charge. Are you sure? You got it. That's why you're. Okay.
Yeah.
It's that one.
Okay, so now we're gonna talk about molecular polarity. So we talked about bond polarity, right? Do you guys remember how to calculate bond polarity? I have to put something out for you guys.
Yeah.
It is.
Does it take?
Bond polarity. So let me see if I can jog that memory that we just talked about yesterday. Just saying. So I said if I have O bonded to an H, O H. Okay, so we have to use the electronegativity, right? So I said I would get you guys that sheet. I have to print it out.
Oh, that's
Table that.
Okay, so we know that the bond polarity, if you guys take a look at chapter 12.
Yeah. And then the dog.
Okay, so if I want to calculate the bond polarity,
Where you were like.
using this table. So what would be the bond polarity of, would it be polar or non-polar? We'll talk about non-polar. So we're determining whether it's polar or non-polar. So if we have oxygen bonded to a hydrogen, is that going to be polar or non-polar? I don't want to hear, I think it's going to be. How would I calculate that?
So you're gonna subtract. the electronegativity of
Okay, so the bigger one from the smaller one. So 3.4 minus 2.2. And that's what? 1.2. So then that would be polar because it falls between 0.5 to 1. Okay, what about carbon and hydrogen?
what are the numbers? Oh, 0.5.
It's right there. Okay, so we have it's 2.6 for carbon minus 2.2. So that's gonna be 0. Okay, so that's gonna be none. Okay, you guys got that?
Yes.
Okay, so that's bond plate. Now we're talking about the molecule. When we talk about the molecule, you guys didn't destroy your beautiful images.
Oh, yes.
Figures. Okay, good. Let me borrow your ammonia. Okay, so when we talk about bond polarity is talking about just the bond between the two atoms. When we talk about molecular polarity, we're talking about the entire thing. Okay, bond polarity is just the bond between two of the atoms. Okay, molecular polarity is the entire thing. Okay, you guys are clear on that, right? Okay, so let me tell you how to calculate molecular polarity. So you're going to have to take in consideration bond polarity. And you also have to take in consideration the bond polarity that's going in all of the different directions. So let me show you an example. So in the case of bond polarity, the one that's most electronegative is going to be pulling the electrons towards itself, right? Okay, so what we're going to do is we're going to take a look at CH4. All right, yeah, CH4, and then we're going to take CHCl4, right? And then what we're going to do, we're just going to change different hydrogens for chlorines. So we're going to add more hydrogens and then so on and so forth. So it looks like this. So here's our CCl4, and this is our CH4. Okay. So the way I like to look at this is how many of you guys have dated twins or triplets or
Like dated them all at one time?
Yeah, at some point. Yeah.
Like they brothers, date the brothers?
Dating brothers. Yeah. You never dated? You never dated brothers or
Maybe I need to
sisters?
try it out.
Exactly. Okay, so this is the way I want you guys to think of it. Okay, so let's say that you're on the dating circuit, and then there are 4 brothers that are quadruplets, right? And these 4 brothers are like they're like doctors, and and so you want to spend time with them. So you want to sit there, and so you're giving your electrons something you want to spend time with, right? Okay, so that's the case of like carbon associating with the chlorines. So there's these 4 quadruplets. All of them are pulling the electron towards it, right? So the electron is going in this direction. So you're giving your affection in that direction. On Monday, on Tuesday, you're doing here. On Wednesday, you're doing here. On Thursday, you're doing there. Now they're perfect. They pay their bills. They got really nice car. They treat you for the best meals. They take care of you, right? Okay, so you want to spend your time with them, right? So you're going to be giving those electrons. So you're being pulled in 4 different directions. Neither of them, are better than the other. They're all perfect in all ways. Okay. Now, let's say you have 3 of those brothers, and then you said, okay, so I'm going to cut one of them loose. I'm going to try some other guy, just to see if it's different. Now, this guy is a deadbeat, right? He don't do nothing for you. Right? He don't pay your bills. He don't take care of you. He doesn't do anything. Or woman, depending on what you're into, so okay. So in that case, you're still going to be giving your affection to this one. You're going to be giving your affection to that one. And you're going to be giving your affection to that one. This guy, you're like, I'm not going to waste my time. Why would I waste my time going that way? So then you're gonna be focusing your energy on those three, right? So then the bond polarity would be towards those
There's
three.
a lot of people to be dating at once.
Okay.
There's a limit.
It's dating. You're not marrying.
It's easier to
It's dating. It's not marriage. Okay? So this first case is you're being spread evenly between all of them, right? So in that case, you don't have a moment, right? Everything is being shared evenly between them all. So you're being pulled evenly by a moment. Okay. Here, the ones that are really good to you are being favored, right? So you're spending all your time with those, and that other one's being neglected. So that's going to form what we call a dipole moment. Okay, because you're spending more time with these guys, the three that are good, than a deadbeat.
Yeah.
Okay. Now let's say we have two good guys and two deadbeats. Okay. So if we have two that are good and two that are bad, are you going to form a dipole moment? Sure.
Yeah, towards those two.
It's going to be towards the two because you're going to favor those two. Why would you waste your time on those deadbeats, right? Because they're deadbeats. You're not going to get anything out of them. So you're going to be splitting it up between those two. And that's it. Okay. So if I have three deadbeats and I have one good guy, where am I going to spend most of my time?
On the one.
On the one good guy, right? So is that going to form a dipole moment? Towards that good guy. Now, if I have four deadbeats, I'm like, oh, my hair, I gotta wash my hair. You know, every day is gonna be washing my hair. Gotta wash my hair. I gotta clean the house, right? So in that case, there's no dipole moment, right?
So what is the definition of a dipole again? I'm sorry.
Dipole basically means that you're,
Attraction or pull or-
it's being pulled. The electrons are being pulled in one direction or the other, right? So electrons, when you're favoring something, electrons are being pulled towards it, right? Okay. So if there's electronegativity that exists, then electrons are going to be pulled towards something. In this case, because there's four, you're being pulled in four directions. Let's try this out, right? Try it here. Okay, so I need three. Give me four women. Okay, I need four women. Come on.
That's too many.
Two more. Why? He can have you know.
You better not cut me off.
Okay, so I didn't know. Okay, I need two more women. Come on, two more women. Come on, come on, come on, ladies. Come on.
Extra credit, 5 points.
Okay.
Right here, go ahead.
Okay. So, do me a favor. You grab his arm. You grab his leg. You grab his arm. You grab his leg.
He never experienced
Okay.
this.
Can we have your consent?
Okay. Okay, so now you guys are gonna be pulling evenly, right? So you guys are gonna be pulling this way, you guys are gonna be pulling out this way, you guys are gonna be pulling that way, right? So now they're
Now
all,
he's gonna be a dead
all-
assistant.
they're all the same, right? They're all the same, so they're all pulling evenly, right? So is he moving anywhere? Right? So he's torn between them, he's like, oh, these beautiful women, they're just all over me, I can't decide, right? So he's not gonna make a decision, so he has no dipole moment, he's not favoring anybody, right? Okay, so we're gonna push you, yeah, that's number
So
one, we're
somebody
gonna
got
push
me.
you up, now I'm gonna pull him, right? I'm gonna pull him, he's mine now, right? So, okay, grab his leg, okay, so you guys, they're gonna be pulling him, right? So then it's gonna be pulling towards him because he doesn't wanna be with me, he don't wanna spend any time with me, right? So then in that case, there is a dipole, right? Do you guys see that?
Yes.
Do you see the distinction between a dipole moment and no dipole?
Yeah.
So if it's being evenly pulled, right,
No,
then there's no dipole moment, right? But if there's a favorite side, there's a dipole moment, right? Electrons being pulled.
do date a lot of women, huh?
Huh? In my day, I have, believe me.
Yeah, a lot of them teachers, I mean, instructors.
Well, you know,
You had them, huh?
you never know until you try,
They was
right?
like that, you had them like that?
You never
You
know
was a
until you
player.
try, you know, so.
Let me see a picture of you from the.
Yeah, how did you say?
I just like.
Reminiscing, huh?
No, I can still swing it that way. I just got a belly now, you know. Some women like that.
You had it like that back when they were.
We'll discuss that at another point. Okay. So when we talk about, let's say, for instance, we're talking about carbon dioxide. Draw the Lewis structure for carbon dioxide. You guys should know this like the back of your hand, right? Drawing. You guys are drawing. Then we'll talk. Carbon dioxide. Oh, CO2. All right, 2 atoms. I'll be taking 2. 2 sets of molecules. Two, 4, 6, 8, and 12. 12 plus 4, 8. 8 around here, 8 around here. Okay. So, is this going to be polar or non-polar? It's molecular polarity.
Polar. No, sorry, not polar.
And why is it non-polar?
Looks like
Is it going to be even sharing? So first, that's the difference between bond polarity. What is the bond polarity of carbon and oxygen? It's 3.4, oxygen is 3.4, and then carbon is 2.6. Okay, is that what that equals? 0.8. So that's the polar. Okay, polar means that you have this guy going in this direction, and you have this guy going in this direction. Okay? So, is that going to be a polar molecule or a non-polar molecule? How many of you believe it's going to be a polar molecule? Based upon what we said, raise your hand. How many of you guys believe it's going to be a non-polar molecule?
Everybody got a vote?
Yeah, so you got 50, you got about 50-50 going on here. I like that. See?
What do you think it's gonna be?
Okay, so when we were pulling, I say, keep that last one. Isaiah. We were pulling Isaiah, right? And then he had women on both sides, right? Was it polar or was it non-polar? Non-polar, why? It was being pulled evenly. What's happening here? Are oxygen on one side and oxygen on the other side? So wouldn't that be even?
yes.
So that means it would be non-polar. 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 And that's where it's molecular polarity. Now, if we're looking at the bond polarity between carbon and oxygen, the bond polarity is polar. Okay, do you guys see the difference?
Yes.
So when we talk about bond polarity, we're talking about just a single bond between carbon and oxygen. When we're talking about molecular polarity, we're looking at the entire thing. Okay, so I'm going to take a moment. I want you guys to think about it, but while I'm gone, I want you to do this. About this. Do these two models. What was that structure? And then I want you to predict the bond polarity, and then the molecular polarity. And it was kind of hard to see on the paper.
I want to put in I was thinking that if there was something I was in what kind of that's another website. I think it tells us on that little chart. How many of those? 6? Yeah. Yeah. But didn't you say there's 6? 6 and S? Oh, I love it.
1 or 2.
Because there's
2, 4, 6.
It's 2.5.
You find busy, so we're calling.
2.5. So whoever has a most.
Tell us
So
about
wouldn't it be oxygen in the middle? Right? So whoever has the most electronegativity? Less? Okay, one is.
Oh, you got two metals?
No, it should be carbon. Because carbon has 2.55.
3?
2.58.
Which one are you doing?
This one.
So
That's
your
the
house,
one.
is your hospital, the hospital
We're
big
doing
here?
I haven't
The
done
nice?
this one. The CSO.
Oh, we're doing SO.
They hire like, what is it? I think
The people.
I don't know. We're in the CSO. I hate it.
The SCSM was on C1.
it's like, is it
Yeah,
like
the
that
S.
work there?
So I was.
A lot of black.
Okay, you have it? Okay, so let's do the first one. Who's gonna be in the middle? Okay. Okay, so. How am I gonna make this work?
Here you go.
Oh, that's a good one. Yes, I did.
Yeah. 2, 4, 6, 8. 8. Yeah. Yeah. Total, 4, 6, 8. Okay. Okay, so is this guy going to be? Well, it's bond polarity, then polar or non-polar? Bond. Okay, so how did you calculate that?
By subtracting
Okay, so tell me.
2.86
So it's 2.86,
minus 2.
isn't it? Isn't it
It's
3 point? It's
2.6 is
2.6.
3.4 minus 2.6.
That's 3.4. Oh.
For sulfur,
Are you able to do it with like 2 lines?
Oh, 0.8.
can you do it?
Yeah, but I took away the
That's the situation.
one.
On the other
left
side.
Do it on both
Yeah,
sides.
do it on both sides.
Oh, that's your negative.
Where I took away another two. Left off of it. Okay.
So,
I can highlight this.
now, even though that sulfur can hold that, it can be, there's 10 around, like 2, 4, 6, 8.
Oh, yeah, I didn't even count it.
So, we have 3.4 minus 2.6, 0.8. So that means polar. Okay, so that means that this is happening over here. Okay, so that's going to be polar or non-polar? Or molecular? Okay, now what about here? It's going to be in the middle. The S.
I just get.
Carbon.
Carbon's going to be in the middle. Okay, so now here, the polarity of carbon and sulfur are the same, right?
Yeah.
The electronegativity is the same. Now, the difference is that carbon likes to be a little bit of a whore, so it likes to be in the middle, right?
Right.
Okay, so you remember that carbon prefers to be in the middle, and it has the opportunity to put me in the middle, right? That's what carbon says. Okay. No bond on the carbon side. On the side. Okay. Now, who's going to be big? What is the bond polarity? Sorry, bond polarity. Bond polarity between carbon and the oxygen. Are they going to be polar or non-polar? 3.4 minus 2.6 is non-polar. That's going to be polar, right? So between oxygen and carbon, it's going to be polar. Now, what about carbon and sulfur? It's even, so that's 0. So then that one isn't going to have any polarity associated, right? Okay. So if one side is pulling and the other side is not, what's going to happen? Is it going to be a polar molecule? Is it going to be a non-polar molecule? So those who say polar, raise your hand. Okay, so let's.
I just don't understand some kind of.
Okay. Let me borrow.
I thought even.
I need to
sharing
borrow
was
somebody.
non-polar.
Can I borrow somebody? Somebody?
Yeah.
I'm gonna borrow you. That's it.
I
Okay.
want you back.
She comes back,
Okay.
but yeah, she's not letting, she.
Yeah. Okay. I want you to grab this side.
Oh,
I want you to. Right, pull, pull, pull. Okay, so I'm not pulling. So is it going towards the direction?
Yeah.
Okay, which way is it going? Towards her, who is stronger, right? Because I'm the weaker one, right? So that's the same thing that's happening here. So is that going to be polar? Or is that going to be non-polar? Polar, because clearly the electrons are moving towards her.
So when it's polar, it's going in that direction.
I was
Non-polar,
right, I was
not
right.
opposite,
But
right?
it's also because oxygen is more electronegative.
Exactly.
That's the big thing.
And that's what we were
That's
talking about earlier.
How much oxygen is more electronegative? It's going to be towards the electrons. She's oxygen. I'm sorry. Okay. Okay, you guys get that? Good. Is that a little bit clear? You're about to fall asleep. That's all right. If you do, don't worry about it. I'll just write in your face and everything like that. Okay, everybody got this down? Feeling confident?
Yeah.
So this is just basically showing you what we just talked about. So in the case of water, right? If you guys do me a favor, make the water molecule. You have to whip this one out real quick. Okay. Hydrogen is white. What? Oxygen is red.
Everyone said it.
You noticed first, yeah.
And then everyone.
Yeah, then we are.
Okay. So who's more electronegative, oxygen or hydrogen?
Who's more?
And yes, more electronegative, oxygen or hydrogen.
Oxygen.
Oxygen is more electronegative, right? So we know that oxygen has 3.4 electronegativity, and then hydrogen has a 2.2 electronegativity. Subtract the two, that's going to be what, 1.2. So is that going to be polar or non-polar? It's going to be polar. So in the case of water, right? We're going to be pulling towards oxygen. So both of them are going to be going towards oxygen. So is the molecule going to be a polar molecule, or is it going to be a non-polar molecule? It's going to be polar because it's going towards the oxygen, right? So the net dipole is going towards that oxygen. Okay. So do you guys see that and see how that differs from carbon dioxide, where carbon dioxide was being pulled out in both directions, right? So then that's being pulled equal ways, right? Where the other one is moving both towards the center. Okay. We're almost there. We're almost there. Home stretch. You guys, everybody's, your eyes are getting so heavy. And taking that exam and studying, huh? Okay, so now we get to talk about organic chemistry. How you guys feel?
Yeah, even inorganic chemistry.
I know, but you're gonna get a little bit of that. I have to give you guys a sampling. You know, I can't let you guys get away with none. Okay, so organic chemistry is basically the study, research, and application of compounds that have carbon. Okay, things are going to be considered to be organic if they have carbon, except for these compounds. Carbonate, so the carbonate ion, cyanide, oxides of carbon, so that's like carbon dioxide, carbon monoxide, okay? So those are the ones that are going to be considered to be still inorganic. Okay, now if you talk to an organic chemist is going to say, no, they belong in our family, right? So you can't get away from them. But in general, if it's carbonate, if it's cyanide, you guys know what cyanide looks like? You should. CN. It's carbon, nitrogen, just carbon, nitrogen. That's the cyanide. It's a poison, yeah, it is a poison. So if you have hydrogen cyanide, it's poison to us. Okay, and then I said oxides like carbon dioxide, carbon monoxide, those guys are considered to be inorganic. Okay, even though that they have carbon. Okay, now any hydrocarbon is anything that has carbon and hydrogen. I shouldn't have drawn it. Anything that has a carbon and a hydrogen is considered to be organic. So ethane is considered to be organic. Okay. Ethane, propane. You guys heard of propane, right? Everybody grills, right? Butane, those who smoke, right?
Oh, yeah.
Okay, so let's talk about those anes, ane and E. Okay. Okay, so hydrocarbons, if they have carbon and hydrogen and they only have single bonds, they're called alkanes. Okay, so if they have only carbon and hydrogen, they belong to a family called alkanes. Okay, and they have single bonds. Now, if they have a double bond, at least one double bond, and it's hydrogen and carbon, they're going to be called alkenes. Alkene. E-N-E. At least one double bond. One double bond. I'll give you guys an example of this. Now, if they have at least one triple bond, they're going to be called alkyne. Okay. So if there are no double bonds, no triple bonds, and they're only single bonds, that's considered to be saturated. It's called saturated with hydrogens. Okay. So, and those again are going to be called alkanes. Now, if it's unsaturated, that means it at least has one double bond or one triple bond. Okay, so saturated fats. What is the difference between saturated fats and unsaturated fats?
Yeah, one gets liquid and then one solid, solid, one out.
Okay, that's true. But what did I just tell you?
One is a single bond, one single bond, the other half.
Okay, so if it's saturated, that means they're all single bonds. If it's unsaturated, there's at least one double bond. Okay, but you're right in terms of the physical features of it. Okay,
These ones don't, so it could be more, right?
they could be more. Okay, so let's start talking about alkanes and how to name alkanes. Okay? So this isn't in your packet, so you're gonna have to bear with it. I'll print it out for you next week. Bring out the wrong chapter. So you guys are ready? We got what? I got 30 minutes.
30.
30, yeah. You guys are out. Technically, you're out at, I just found out.
Well, it's too
last
late
week.
for that now.
I found out last week that
It's
you
too
guys
late.
get out at 2:10.
It's too late for
No,
that.
it's 2:05.
2:05?
Well,
On the thing, it says 2:10.
I wouldn't be coming to that day, that's too
we'll
long.
be quiet, let you teach.
I like
Let's
it.
go.
I like it. 2:10, isn't it 2:10?
No.
Yeah,
You've been spoiling us. Don't start now.
12:05, right? 12:05. I like 2:10 better.
That's ridiculous. That's a whole shit, what shit?
Why did we get it?
I ain't gonna say
Why is
what's
it 10?
The same children? Shut the hell up. You're lying.
No, I haven't.
We've never called you stupid. Maybe she had mine. No, my brain.
Okay, so. Yeah, we've got prefixes. You guys are familiar with. Okay, now I'm gonna teach you some more prefixes. So, if it's meth, that's gonna be 1.
Oh, yeah.
Meth, 2. Pro equals 3. U equals 4. Ent equals 6. Yep. 7. 8. No. Equals 9. Deck. 10. Deck. 11. No deck. 12. Try deck. 13. Okay. Now, if it's all single bonds, right? A and E. So it's going to end with A and E. So this would be prefixes. Suffix.
So we need to know all this right here.
Yes, we do need to know this.
Write this down, bro.
Okay. So if it's A and E, all single
This
bonds. If it's A, any is, so alkenes. What is alkenes? They have to have at least what? At least a double bond. And if it's Y and E, at least one triple. Okay. So when we talk about hydrocarbons, there are a couple of ways that we write the structure or we write the chemical compound. One of them is the classic way that we write the chemical compound. C4H. C4H10. Now, us writing it this way, it doesn't help us realize how many of them are double bonds or triple bonds or single bonds, right? You guys can't tell. It's hard to tell that way, right? So the way that we would do it is there's a couple of ways that we could write this down. This is the classic formula way. Another way would be writing it down as C3 C2 CH3. So this here is called condensed. So this is the condensed way of writing. Same thing, right? That's 4 carbons, four hydrogens, 2 carbons, 2 carbons, plus 6 more hydrogens.
Multiplying, is that a dot? Multiplying them?
It's a dash. It's a dash. Sometimes I'll do it for a dash, but sometimes I'll just write it just in the letters. What was that? This would be condensed. So this is classic. Classic. Classic condensed. Okay. Expanded would be this will be expanded. Okay. Now, having to write this down, right? If you're getting down to tridecane, right? That's 13 carbons, right? Having to write that expanded, it's just like crazy, right? It gets so insane. So we have another way of doing it. Okay. This one is called skeleton. Skeleton. So each point represents a carbon. So this is a carbon, That's a carbon, that's a carbon, that's a carbon. 1, 2, 3, 4. You don't put any of the hydrogens because it's saturated with hydrogens. So you put, because carbon can have 4 attachments. You guys remember, did I show you guys the chemical party? Remember there were 4 people were attaching to them?
Yeah.
At most 4 carbon can have 4 attachments. So that means that this is 1 attachment with the other carbon. So that means that there has to be 3 around here, right? Since this carbon has 2 attachments, 1, 2, that means there has to be 2 hydrogens here, and it's understood. Okay, so this is called skeletal. I can't spell S-K-E-L-T. It still doesn't work right. Okay, skeletal. Okay, expanded. Now, look how fast I wrote that down compared to this and that and even that, you know. And here you can kind of get an idea of what it looks like.
So what's the skeletal representing? Like
So
where's everything
each-
supposed to go?
Each point represents a carbon. So this here, that would be a carbon. This here would be a carbon. This here would be a carbon. And this here would be a carbon. Okay, so then they're bonded to each other. And then it's understood that the rest of it has to be hydrogens. And carbon has 4 attachments. So that's 1, 2, 3 hydrogens here. This one would have to have 2 hydrogens. This one would have to have 2 hydrogens. And then this one has to have 3 hydrogens. You understand? You see that? So it's the same thing that we have here. I think it's being drawn up. It goes for anything that's organic, right? So, and now we're going to go through it because you're going to get a couple of things because you guys need at least know alcohols. You're going to learn a couple of things. Can't learn everything. Okay. Okay, so this guy, see, since there's 4 carbons, 1, 2, 3, 4 carbons. We go down here, 4 carbons will be bute. And then since they're all single bonded, we use the suffix ane. Butane. Okay. So,
Okay, how much is that?
so if we have C4H8, right? C4H8, so then that's going to be well, it could be CH3H. Or mind if I erase the C4? Erase this guy. Did everybody get the other part out? This part? Because it's Ethane, right? And you have in the middle has a carbon hydrogen.
Where is that?
Okay, so then it's
I see one over here.
this one would be C.
It's probably the same one.
There, over there.
A roach.
Just like this big.
Oh, I gotta go.
It's like a roach.
Step on it. Y'all scared?
Oh.
I don't got time for y'all.
It's on top, so I can't step on it.
Step on it.
And you know, white Air
It's like
Force.
on the door. I'm just gonna see.
Y'all scared of roaches? I hope y'all were scared of roaches. With your hand.
Did you kill it? No.
Okay, So this is the expanded, right? So now the thing is that when we write this, right, it could have been this way, right? Or it could have been here, I'm gonna make a change here. Where it was CH2, CH, CH2,
I think you said wrote it.
CH3. So it could have been this way, it could have been, because this one could have been this one, and there could have been another one. Right? So it could be this expanded version, or it could be this expanded.
Yeah, barely.
Yeah, there's spots that you can start. Okay, so these guys are different. This is an example of an isomer. Remember, I told you there's going to be a lot of isomers in organic chemistry, so you need to be able to distinguish them. And the way that we would name these are going to be different, right? They're going to have the same basic name. We know that this guy is, it's 4 carbons, which would be U. We have at least one double bond, so then we end it with E. So butene. Okay? Now, what we have to do is we have to number our carbons. The way that you number your carbons is based upon where your structure is at. Where is that double bond located? Right? So you want to give the double bond, the location of the double bond, the lowest number possible. So if we start counting from here, that's 1, that's 2, that's 3, that's 4. Okay? The lowest number possible. We're gonna give it the lowest number possible. Don't worry about it. If it comes towards it, you'll know, right? Just let it go, let it be. It'll live for just a minute. There's a couple of nerves that are here that'll knock it out. You always see them flipped over, right?
No, this one was
No,
crawling,
this one-
He
having
was still
fun.
around. Don't worry about it. He'll die in a minute. So
He was having a time of
okay,
his
so
life.
that's 1, 2, 3, 4, right? And then if we count it the other way.
We could have.
1, 2, 3, 4. Okay, so we know we have 4 carbons, so we know that it's going to be a butene. Now we have to say, where does that double bond start? You want to give that double bond the lowest number because the double bond is more important than all the single bonds. Okay, it has priority. So you want to tell me where that double bond is going to be at. You want to give the lowest number possible. So is 1 lower than 4? Or 1 lower than 3? Right? So 1 is lower than 3. So we would call this guy 1 butene. Where this guy we would call 2. Yes, you're giving me the location of the double bond. You tell me where the double bond starts at. Okay, it's where that double bond, or in the case of the triple bond, starts at. Okay, pretty simple.
That alone.
Oh, it does, right? These guys behave differently. They're going to react differently, right? So in one case, they may react. In another case, they won't react, right? My students, I wish actually he did this experiment, and I was switching out because I had 1 butene. I didn't have 2 butene, and they couldn't get anything to work, right? And then I look back and I'm like, oh shit, I gave the wrong one, right? And they spent the whole, it's a 5-hour lab, right? So they spent a 5-hour lab trying to get the damn thing to work, and it wouldn't work. Oh, they were so mad at me. So that is an example, right, of why things, you have to pay attention and you have to write it down the right way. So these guys are isomers of each other, right? So because structurally they're different, right? They have the same chemical formula, Same chemical formula, different chemical structure. So it's important for us to draw the structure. So that's why the skeletal structure becomes important. So the way I would draw the skeletal structure for this guy would be 1, 2, and it's on the second carbon, right? So that's 1, 2. So we draw a double bond here, right? And then we draw, so that's 1, 2, 3, 4. Okay, so that's how we would draw this one. Now, so how would we draw this one? It'd be a double line at the beginning. Single. No. So that's skeletal structure for that. Can you guys see that? The bottom one?
Not
There
the
we go.
routine, but
Okay,
everything else.
so are you guys with me so far?
Yeah.
Okay. Now, we won't talk about trans and cis yet. Right?
Why is this even, why do we have to go to this? Why is this like?
Because you gotta learn this, it's all part of it. Right? It's part of it, because we do talk about ethane and ethanol and so far, have we talked about ethane? Combustion reactions, we have not talked about combustion.
They were hard. They were hard.
Yeah, the whole lesson is all. It's all organic. It's organic. That's just named it. Did you come over here and visit you guys too? Got it? When I was, so we had a they were on the average. And they were part of the pack. They didn't come back.
How big were they?
Where was that?
So there's a group, there's a one. Oh, yeah, they would come.
Did they bite you?
Oh, they were.
The roaches bite?
Yes.
Yeah.
They hurt me?
Yes.
You
I
got me
don't
by
know
roach?
theirs, but I never got bit. I never.
Roaches bite?
I never let me too close.
They really bite.
Wait, you're kidding. Roaches bite.
And this one technician, she just started, and I felt so bad for her. There was these 2 roaches that escaped, and they were going for her. I mean, they escaped, well, because they were like, they
So
were
I never
part
heard
of a
roaches
ladder
bite.
scrape.
How you get the right roach?
So, man, they were just like, they were after her, and she was running down the hall. She didn't come back after that. She was one day.
Do the roach bite hurt
I
though?
have a phobia of them.
It didn't get close enough. She was sprinting down the hall. They were coming at her. They were like literally coming at her. They're trying to get her to come back in the building. She's like, I am not coming back in that building. That's what she did. She didn't come back. We had to bring her stuff out and everything. She would not come back in the building. Okay, so we're gonna stop here. We'll pick this back up tomorrow. We're gonna go tomorrow. The first hour and a half is gonna be a lab. You guys gonna be doing lab number 5, and then so that means that we go through an hour and a half later, and then we're gonna talk about organic chemistry a little bit. We can't get too far into it, but yeah. If you just want to, you can FaceTime with your group tomorrow. That's actually a good
I'm
idea.
staying. Are
Okay,
you staying?
great, and I will see you guys. No problem. You guys want to eat some lunch today?
No, you go. I guess it's. That's okay.
Yeah, everything like, oh, now I'll go to like open. Yes, girl. It's gonna be like.
Oh, it's so cute. I love it. I'm just sad.
Yes.
Yeah.
What's the other side? The other side.
Or we can fix that tomorrow.
I thought.
It's not very
If we get the light.
You don't have to. Extra credit and like. You don't have to.
No, no. I actually.
Okay.
Oh, and they can fly too.
No problem.
That one looked like it
It
had.
wasn't good? Okay, wait, before you guys go, how many people were happy with the exam?
disappointed.
Very.
With your score?
I was.
I did
I
better
gotta wait
than
for the
last.
full thing, but I feel like
I did better than last call, but it's still.
I did 4 points more than last time.
Okay.
Was it easier? Yeah, I think so.
I think that it's
It was easier or no?
You guys feel it was better than the last one?
No, no,
Kinda,
it's
yeah.
like 50-50 with class, no.
I think the last one.
It was like 60-40. But still, I still think I still didn't understand. I wanted to like close my eyes and just click, but I was like, nah.
All the skin, like, the word questions are like,
That's what
No, it's gone.
It's gone.
I'm telling you. This.
I think it was better.
Yeah.
I was gonna suggest that I'll give you guys, as I said, tomorrow I'll give you guys your third exam. It's gonna be a take-home exam. It's a group exam, you guys can work in groups, you just gotta let me know the group that you're working with, everybody that's in there, and you guys can't have, everything can't be verbatim, right? So you gotta have a little difference between it, in other words, I don't want you to turn in the exact same work, I want you guys to show me, there's some distinction. And you guys should honestly discuss things, because if you don't, you'll get burned. Typically what happens is that you rely on that really smart person, and that really smart person has a bad day. Let me give you an example. I had a group that was in fireball, they relied on this one guy, and everybody depended on him except for one person. And I told them, I said, you guys want to discuss it? They argued for a little bit, and one guy was arguing with him, everybody else was just like, yeah, whatever, and didn't even pay any attention. So half will say 2/3 of the class failed and 1/3 of the class passed, because we rely on that smart guy and that one person. So you want to definitely discuss the answers, right? Because that's going to lead you down the right path. Okay. So, the point of it is to get you guys to work as a group, as a unit, to produce a quality product. But it's going to be your quality product. It needs to be somewhat unique, but yet still have aspects of you guys working. You guys understand what I'm saying? Okay. Okay, and it's also the hardest part of this class. So it will be a really hard exam. Yeah, I'll have it ready tomorrow night. So it'll either email to you guys, it'll be online, so you guys can download it, and then I'll give you a hard copy. So, and then I'll give you guys, you'll have about 2 weeks here. Okay. Yes. What was that? Oh, yeah. Good. Okay, so let me guys, so if you guys want to, you guys could,
Oh, they're right
then we're doing part of it, but then you guys can. Where's your other hat?
Oh, okay. Yeah, I know, we start.
It will be the same extra credit.
Okay, because we don't. I'll
give you that. Normally it doesn't change.
Yeah.
You're just gonna leave me your. I don't know. I know. I haven't. I know. I can just stay here all day. You're drinks, right?